All right, here we go. Bit of a step back today. Nice day to catch up and review the main derivative rules that we have learned. And we're going to practice seeing them when they're combined and then seeing them when we don't have all of the info. We don't even really know what the functions are, but we have enough information from a table or a graph to find certain derivatives at points. So we know the power rule, we know the product rule, the quotient rule, the chain rule, rule for taking derivative of sine and cosine. These are things that you need to start memorizing, and while you're on the road to memorizing, make yourself a pretty sign of it, post the sign where you usually do your work, post that sign to GroupMe for some extra credit. Just start to get these things into your brain. So quick review, right? These rules can be mixed together. If we had f of x is 5x times the square root of x plus 3. I don't even really think about this until I've first taken that x plus 3 in a square root and converted it to an x plus 3 to the 1/2. Well, what do we have here? We really have a 5x multiplied by an x plus 3 to the 1/2. So what we first have is the product rule. F prime times g, this is the easy one, f prime times g plus f times g prime. I'm going to leave this. I'm going to say I'll do this in a step. I just want to take this one step at a time times the derivative of x plus 3 to the 1/2. The reason I do this in a separate step, right, f prime g plus f, notice my mistake, I'm glad I reread it, plus f times g prime is just so I can get partial credit if I now mess up the chain rule. So the chain rule would tell me that this derivative here is going to be 1/2 times x plus 3 to the negative 1/2. Well, you'd get lucky if you forgot the chain rule because it's just the derivative of x plus 3, which is 1. So that one doesn't end up really mattering too much there. And so if we put this all together, what we would have is 5 times the quantity x plus 3 to the 1/2 plus 5x times 1/2 x plus 3 to the negative 1/2. AP free response question, you are done. There's no need to simplify anymore. You can be totally done. Let's do one more just quick review before we move on to tables and graphs. We could have chain with something going on inside of it, right? So we have a chain rule here because it's the sign of something that's not just x, something that's 2x plus 1 over x minus 3. So the first part of the chain rule is going to be pretty straightforward. It's the derivative of the outer function. So sine, we know, becomes cosine with g of x on the inside. The inside function just gets plugged in. Chain rule says, though, times, and notice again, I'll do this in 2 steps, times the derivative of 2x plus 1 over x minus 3, which annoyingly is going to require the quotient rule. And so we're going to have to put all of this together. So we're going to have the cosine, I might run out of room here, of 2x plus 1 over x minus 3. And this is all going to be multiplied by f prime g, so 2 times x minus 3, minus, and I like to put this in a big parentheses or even a bracket, f 2x plus 1 g prime, the derivative of x minus 3 is 1, all over x minus 3 squared. Now, we could probably clean this up a little bit, but I want to start getting us in the habit. If this is a free response question on the AP exam, you are done. As soon as you have, and sorry, I'm being sloppy here. I didn't actually write what we were doing. This is the derivative of f. This is the derivative of f. If you are down to a free response question here, you are done. You don't have anything left to do. Once you're down to just this pure algebra, you can stop there. But just, yeah, so we can have quotient rule inside chain rule. We can have product, then chain. We can have all kinds of things going on here. Another way that this information could be assessed, your knowledge of these rules, is if you have tables that tell you just enough information. And so let's say you have this table of values. We have our x values, so our inputs, right? And then we are given f of x at those inputs, g of x, f prime, and g prime. If we're trying to find h prime of x, h prime of x, just purely applying the product rule, will be f prime of x, g of x, plus f of x, g prime of x. Now, we don't actually even know what f and g are, but we can totally find h prime of 4 because we're just plugging in and we have all of this information. We can find f prime of 4 and multiply it by g of 4. We can find f of 4 and multiply it by g prime of 4. It's literally a matter of just looking these values up in a table. F prime of 4, well, f prime of 4 is 8, times g of 4, well, g of 4 is 7, 8 times 7, plus f of 4, we know f of 4 is 1, times g prime of 4, g prime of 4 is negative 2. Again, if you're on a free response question, you are totally done. You could stop there. You could also say, okay, yeah, that's not that bad. That's 56 minus 2, that's 54, but no reason to risk it if you don't have to. Just a couple more to get this idea solidified. If we wanted to find, this should say, obviously not g prime of 3, this should say j prime of 3. We would need to use the quotient rule. So we would need to find here, I'm going to skip ahead, j prime of 3 is going to be f prime of 3 times g of 3 minus f of 3 times g prime of 3 all over g of 3 squared. And so just pulling these values from the table, f prime of 3 is negative 4, g of 3 is 4. Minus all of this in one unit, f of 3 is negative 5, times g prime of 3 is 6. All of this over g of 3, which is 4, squared. So again, you could work this all out. You get like negative 16 plus 30, whatever, 46 over 16. On the AP Calculus exam, you can be done here. I'm going to really start hitting this hard because I want you to save as much algebra time as possible, focus on the calculus. Your answer is done there once the calculus is done and you're left with just algebra. 2 more on this, and then we'll see what it looks like from a graph. Let's see, just really quickly here, run through a chain rule. So if I wanted to find k prime of 2 and k was f of g of x, I know my chain rule. This is f of g of 2. F of g of 2. Let's change this. I'm just doing something on the fly here just because I realize this is not going to work. Let's do of 3, and you'll see why it's not going to work in a second. So I'm going to back this all out here. We're going to find, instead of k prime of 2, and you'll see in a second, this will be a good clue. This is how I knew I did something wrong. It'll be how you knew you did something wrong. If I go to find k prime of 3, I need to find f prime of whatever g of 3 is and multiply it by g prime of 3. Well, working our way inside out, I don't even know what I'm finding f prime of yet. I need to figure out what g of 3 is, and then I'll find f prime of whatever that thing is. G of 3 is 4. G of 3 is 4, and we are going to multiply that by g prime of 3. G prime of 3 is 6. And here's how you can see, here's how I knew I did something wrong. When I first wrote this, I just kind of picked one at random. I said, okay, we'll find k prime of 2. K prime of 2, right? If we looked up g of 2, g of 2 is negative 1. So when we go to find f prime of negative 1, it's not one of our x values. So you'll know you've done something wrong if that ends up happening, which is why I had to on the fly change this to g of 3 because it works like the following. First we found g of 3, And then via the chain rule, we're going to find f prime of 3, which is, sorry, f prime of, we found g of 3 was 4. Now we're going to find f prime of 4, which is 8. So one more time, because this is a really tricky one. This is f prime of g of 3. It takes 2 steps. G of 3 is 4. G of 3 is 4. Then we found f prime, not of 3, but of 4, because that's what g of 3 was, and that gave us 8. So this is going to be 8 times 6 to get 48. Last one here on these tables. I just want you to know you can combine things from the table and not in the table. So let's say I wanted to find the equation of the line tangent to q of x at x equals 4. Every time I see that, what's my point of tangency? What's the slope of the tangent line? Well, the point of tangency is going to be 4 comma whatever q of 4 is. So q of 4, well, we're plugging in for x, will be 4 squared times f of 4. F of 4, looking back at the table, f of 4 is 1. So we'll have 16 times 1 equals 16. So we'll have 4 comma 16. Halfway there. The slope of the tangent line at 4 will be q prime of 4, which will require the product rule because this is the product of x squared and f of x. So we'll have 2x times f prime. Let's just, I'll back this up here for a second. We'll just talk about this as q prime of x first. 2x times f prime of x plus x squared. Sorry, 2x times f of x, because it's the derivative of the first times the second, plus the first x squared times the derivative of the second. Now we can plug in q prime of 4 is 2 times 4 plus f of 4 plus 4 squared plus f prime of 4. That's a doozy. So we're going to have 8 plus f of 4. F of 4 is 1. Yeah, we already knew that. F of 4 is 1 plus 16 plus f prime of 4 is 8. F prime of 4 is 8. And so we put all of that together, and we're going to get 9 plus 16, 25, 33. So we have a slope of the tangent line of 33 there. So our equation would be y minus 16 is 33 times x minus 4. Woo! Okay, so the idea here, you start to just write out what your rule tells you, and then when you get stuck, you look at your table of values to find that information. We can take that one step further. Instead of being given a table, let's pretend we are given graphs. So if we're given the graph of f of x and g of x, and we're told that p is f of x times g of x, same idea, find the equation of the line tangent to p of x at 4. So I need to know, what is the point where this line is tangent to p of x? Well, it's going to be 4 comma something. P of 4 equals f of 4 times g of 4. Well, f of 4, I can see, is just negative 3. G of 4, I can see, is 4. So negative 3 times 4, this is negative 12. So there's our point of tangency. Now, this is the fun one. If I wanted to find p prime of 4, well, first, that's going to require, well, let's find p prime of x first. That's going to require the product rule. So we'd have f prime of x times g of x plus f of x times g prime of x. And p prime of now plugging in 4, and again, once you've done this a bunch, you can kind of skip right to that step, times g of 4 plus f of 4 times g prime of 4. We already know what g of 4 is, that's 4. We already know what f of 4 is, that's negative 3. The trick here is, how do we know what f prime of 4 is? As always, it comes back to the most important sentence in calculus. F prime of 4 is the derivative of f of x at 4 is the slope of the tangent line at 4. Now in this case, the tangent line, this is just a straight line. So the slope of the tangent line is the same thing as the slope of the actual line, down 1 over 2. So f prime of 4 equals negative 1/2 versus f of 4 equals negative 3. Notice f of 4 is just the point. F prime is the slope, or the slope of the tangent line. So we can replace f prime of negative 4 with negative 1/2. Do the same exercise for g prime of 4. G prime of 4. Okay. G prime of 4 is actually going to be, this is a bummer, G prime of 4 is undefined. G prime of 4 is undefined, so this is actually not going to work out. This is going to be times something that's undefined. So we are going to have a tangent line that is undefined and has no slope or cannot be determined. But we do have a point of tangency. So what that means is this is just going to be a vertical line at y equals negative 12. That's a bit of an oddball one. Usually you would have something here, and that would wind up giving you the slope of the tangent line. So let's see, is this one? Yeah, that one's going to be a little bit, I want to leave it at that. 17 minutes is enough here for today. This will give you enough to get started on the delta math.